Welcome to Rolls-Royce University Technology Center in Manufacturing and Engineering Technology at the University of Nottingham. My name is Abdul Khalid Mohammed. I'm Assistant Professor in Mechatronics at the UTC. Today we would like to show you our latest technology in developing robotics for in-situ inspection and repair. Today we are going to show you three different types of robots. The first one is a COBRA robot, which is basically a 5-meter snake-like robot. The second one is a Hexapod robot, and the third one is a dog robot. So we started developing such kind of robot almost 10 years ago, and the motivation behind that it is that for Rolls-Royce it's very costly and time-consuming to take off an aero-engine from the aeroplane in order to do inspection and repair. As the inspection and repair inside aero-engine is very challenging because the available working space is very limited. So it is we cannot use conventional industrial robots. So we developed this kind of robots, which is we call them snake-like robot or continuum robot. Here we have our team today will help us to do demonstration. We have Luca working on the COBRA robot. We have Josue working on the Hexapod robot. We have Candy and Elias who will help us to demonstrate the dog robot. So if we start with the COBRA robot, Luca, if you can give us
Yes.
more information about the COBRA robot.
Thank you, David, and thank you for joining Target Robot. So yes, like David was mentioning, this COBRA robot is one of our newest snake-like robot. The system is composed of three main elements. We have the feed and twist mechanism that basically drives the snake robot inside the application. We have the actuation part that contains all the electronics and the motors to drive the cable-driven system inside the robot. And finally, we have the computer, in which, in this case, for example, we can see the output of the camera on the tip of the robot. The robot can be used for a plethora of applications, going from inspection in constrained spaces, going to aerospace, up to medical field. In this case, since it is for a medical application, for inspection inside, for example, like an endoscope, we just have a camera with some LEDs that basically shine light through the darkness of the throat of the patients. But we can put on the tip of the robot also others, any kind of tool, going to lasers or to other kind of milling bits. I'm going to show you now the system. Here we have the joystick with which I'm going to drive first the robot inside the mouth of the dummy patient. I'm passing now through the teeth and entering in the direction of the throat. Then I can use the cable-driven mechanism to rotate the robot and have a better view of the inside of the mouth of the patients. Now I'm going to retract the robot, so I'm going to show you more clearly the capability of steering the teeth through the cable-driven mechanism. And as you can see, I can remotely operate the robot. The big advantage of this system is that it's not only remote, meaning from here to here, but can also be remotely from two different locations through wireless connections. And as you can see, that can be very useful, for example, for inspection in aero-engines or for medical application where I have a limited number of very qualified doctors or engineers doing inspection remotely and not having to be deployed directly where the application is.
So Luca, have you demonstrated like a remote operation of this kind of robot?
Yes, we did it from Derby to Sheffield, and basically we succeeded in this. That is not the first time we did this. We also did in for other projects, for example, in Rainer. And like I was saying, the key factor is to have a limited number of very qualified engineers or doctors that don't need to be deployed all around the world.
And how long does it take you to develop this robot?
The development of this one was around 3 years. Let's say that is roughly the standard for all robots. Of course, since we are kind of expert in this, and I would say in the world of snake-like robot, we are some of the most qualified group in the world. The development time is getting shorter and shorter, but I would say a few years is what you should expect for a full robot to be deployed.
Thank you very much.
Thank you.
Yeah. So the second type of robot is Hexapod Robot, as you can see here. And we started developing this kind of robot also almost 10 years ago, where Rolls-Royce came to us and asked for a solution to do machining of a very large component where the component cannot be taken from where it is located to a workshop in order to do, for example, drilling of M42. So we developed for them at the time what we call the free Hexapod, which is basically a machine tool which can be carried by a human operator and attach it against the workpiece and then start to work, make the drilling or the machining in general. After that, we found that it depends on the human operator, so we would like to take the human from the loop by developing what we call a walking Hexapod. So basically, it is a walking machine tool which can walk into the intervention location and start doing the machine. And this is the latest technology we have developed for the Hexapod robot, which what we call it the rail Hexapod. And Josue, if you can give us more information about the rail Hexapod and how it's different from the previous variant of the Hexapods.
Thank you, Khalid. Well, basically, the idea of this Hexapod is that we are enabling other capabilities. And as Khalid was mentioning, the idea behind it is to make a system which is able to adapt to different environments. And for that, we included a clutch mechanism, which basically can modify the structure of the system and allow other capabilities, such as increasing the workspace and increasing the stiffness. And the idea behind that is that we are bringing machining capabilities to hazardous environments. And to do so, we have a tool that we have attached to a platform. And the position and the orientation of this tool is controlled by modifying the orientation of the platform. To do so, we have 6 links working together. And by means of extending them and retracting them, we can move the tip of the tool to do, for instance, drilling operations or milling operations. And we also will be showing some videos of the system working. But basically, the idea is that we can control the orientation of each link individually by modifying these three cables, and by contracting and extending each link individually. And in order to work on metallic surfaces, we have also included these magnetic feet, which work in a passive active way, basically on and off, as we are displacing over, let's say, different environments. And when we are doing the machining, we keep them on in order to attach it to the surface. And in general words, this is the description of the ring hex. Thank you very much.
Thank you very much, sir. We would like also to mention that this rail Hexapod is developed under EBSRC Research Hub, which is rail, robotic, and artificial intelligence in nuclear. And it is developed to do this machining task in a nuclear environment. Also, I'd like to make note about the COBRA robot, which is developed in Innovative Care project led by Rolls-Royce. As I said, these two robots, we developed them from scratch in the UTC, including mechanical design, manufacturing, sensors, actuator, everything, including the control as well. But in the UTC also we deal with the off-the-shelf robot. Today, here we have our dog robot, which is off-the-shelf robot. We call it Alex. Alex actually is used in the UTC in order to do mapping of working environment, for example, the manufacturing environment of an aero-engine, where the human operator cannot reach. So just simply by adding a camera on it and using developing some SLAM algorithm, we can map the environment. We have Shonshu, who is now giving the control to Elias Ahmed, who left his school in order to help us demonstrating this nice robot. So it is quite easy to be controlled, as you can see. It is simply by a joystick. Yeah, now it's trying to get out of this obstacle.
Okay.
Oh, oh. Be careful, be careful. Back now, back now. Yes, very good. So now we are very happy to have any question from you. Thank you very much for your attention. And if you have any question, please type them in the chat. Oh. Thank you for the question. For the snake robot, COBRA robot actually is a 3 years project. We built all of the experience which enable us to quickly develop a new version of it. So, for example, in this project, it takes 3 years to develop the full robot. But if we would like to copy it, I think it will not take us more than 3 months. Yes, the dog robot can run almost similar to the human walking, like 5 to 10 kilometers per hour. Yeah, please.
That depends. The idea is that we can modify that workspace, but basically it's confined between the legs of the hexapod, and that has a diameter of around 500 millimeters. So we can imagine it as a sphere of 500 millimeters radius.
Yes, this depends, and it does not depend on the robot itself. It depends on the camera and the processor attached to the robot. So if you have a computer which can take a lot of data, it can scan as much as you can. As I said, it is not related to the robot. Maybe it is related only to the battery size of the robot. This is a good question. I think it should be around 70 to 80 degrees centigrade. We have previously in an EU project, we combined the snake-like robot with a walking hexapod, the previous version of this one. The snake arm at the time include 24 degree of freedom, and 24 degree of freedom also for the walking hexapod. And this to do also inspection of a confined space where you cannot take the snake arm by a human operator. Actually, we have also some, I think, some robot inspired by flying animals, in order to develop flying robot. Yeah, we have tried doing the image processing while the robot moving in a normal speed, and we could capture most of the environment features and successfully build a map of the environment. The application for this is machining of a large component in situ, where you cannot take the large component to a workshop in order to do the machining. So imagine you have a very large component in a nuclear site where you cannot send a human to do the operation, and also you cannot take the part itself to a workshop in order to do the machining. So here you have two basic functions. The first one, you need to do the machining in situ, and second one is to send the machine tool over there. So this is a very reasonable application for the hexapod. The snake robot, yes, it is still operated. We have demonstrated operating it in Derby, while the operator control it remotely from Oxford, in Derby, where Rolls-Royce engine were. and Oxford were raised as the other partner of this project, demonstrate to control the snake arm, as I said, from Oxford, using a high-level controller with a joystick. For the Hexapod, currently the controller and the machine are connected with a wire, but yeah, the concept can be easily demonstrated using the remotely controlled. The dog robot clearly it is teleoperated with a small distance somehow. So here we have Gonzalo asking if we are using the same material to build the robot for nuclear environment and to treat the people. This is a very good question. For the nuclear environment, we know that if you have a robot and you send it to a nuclear environment, it is very likely to have to be affected by the radioactive material. So for that, we propose to include a very thin slab on the body of the robot in order to take any kind of nuclear effect on the robot. This is the first point. The second point, all of our snake arm or snake robots consist of purely mechanical parts, so no electronics attached to the robot, so it will not be affected by the nuclear environment. For the other part, which is a medical application, of course, we consider to use bio-compatible material because it can be very safe for the human operation. Thank you very much, Gonzalo, for your question. Hopefully, I answered your question as well. The Hexapod is around 40 kilograms. Javier here asking how much is the weight of the Hexapod. So it is 40 kilograms. And it can carry up to 70 kilograms of load. Gonzalo asking question, what is the material we are using for the snake, for the cable of the snake robot? Thank you, Gonzalo, for your question. We use steel cables. Maybe I can ask Shunshu to help me to answer this question. Thank you, Kieran, for your question. How long does it take the battery of the robot? The dog robot?
Yeah.
How long does it take?
You mean the life of the battery?
Yeah, of the robot.
Almost up to, I'm turning 4 hours.
4 hours.
Up to 4 hours.
Yeah, up to 4 hours. Yeah. Thank you. So, Maratha, thank you for your question. What is the distance that the snake can reach? Yeah, it depends on the length of the snake arm. For COBRA, it is 5 meters, so we can reach 5 meters. And yeah, for this version, it's 1.5 meters, so it can reach 1.5 meters almost. The speed limit, thank you, Martha, for your question. What is the speed limits of the Hexapod? The current speed of the Hexapod is 10 millimeter per minute. 100 millimeter per minute, which is quite slow. But as I said, the Hexapod is basically developed to do machining with high precision. It can reach up to 100 micrometer of a precision. And the walking is some kind of additional capability in order to enable the machining in situ. Yeah, thank you very much, Gonzalo, for your question. For the COBRA robot, it is already reached TRL 6, and we are now working on commercializing it with Rolls-Royce. Yeah. we receive a lot of interest in this particular robot. Thank you, Martha, for this question. Are you planning to implement artificial intelligence? Yeah, we already started to implement a lot of artificial intelligence, like neural networks here in our robots. For example, for the snake-like robot, it is very difficult to do like the control of the position due to the limitation of the sensors. So we have some PhD students working on developing neural networks and artificial intelligence in order to improve the closed loop control of it. Thank you for this question. Yeah. For myself, I'm more like the cats more than the robot, as the dogs. Yeah, and I hope at some point we can do a cat robot. Yeah. Thank you very much, Zan, for your question. So your question basically about the accuracy of the snake-like robot and how we can make sure that they are at the correct position. So for the COBRA robot, we have a fiber optic sensor, and this fiber optic sensor can be attached inside a working channel inside the robot. So here inside the robot, we have a 3 working channels, so we can send any kind of sensor or tools. So we insert a shape sensor, which can basically give us indication about where each point of the robot is located with a very high accuracy. So based on this, we can implement a feedback controller in order to adjust the robot to the required location. Okay, thank you, Martha, for your question, which is which are the improvement or next steps for your 3 robots? Okay, basically for the COBRA robot, one of the improvements we are doing right now is that the passive part, if you insert it, for example, in a large space, so it is very difficult to adjust the robot in a large space, if you can imagine, because the robot itself is, the passive part is not controllable. So what we are developing right now is to have an inflatable balloon, which can be attached to any location of the robot. So this inflatable balloon can rigidize the robot against the environment, so it can be more controllable. For the Hexapod, I say, Jose, can you help me answering this question?
Yes, sure. For instance, one thing we have foreseen is that we need to develop systems which are highly adaptable to different systems. And basically, some of the things that we have learned from our experience is that one of the things that we have to keep constantly in mind is make systems which are easily transported to the place of intervention. So basically, we are targeting to create adaptable systems and live systems.
Yeah, thank you.
Thank you.
Yeah, for the dog robot, actually, there are a lot of, I think, environment where we can improve. If we look to the low-level control system of it, so its dynamic system can be improved as well. Think somehow also the battery life and this kind of stuff in order to allow it to survive for longer time. Yeah, the accuracy also of the SLAM algorithm we developed needs some improvement. So this is actually the most active area we are working on. So it's the accuracy of the SLAM algorithm we developed. The current, thank you, Karen, for your question, which is the snake robot is waterproof? The current version of the robot, it is not. But another important point that all of the components of the snake-like robot, I mean the robot body, is a mechanical parts. So it is by default, it can be regarded as a waterproof, but it needs a little bit improvement in order to be fully waterproof against corrosion and some this kind of things. But as I said, the mechanical parts, the body part of the snake arm is just purely mechanical parts, no any kind of electronics inside it. Thank you, David. David Alatori, who is work mainly on developing this COBRA snake arm. Thank you very much, David, for your hard work on this robot. Without it, this robot could not be here. Okay. Thank you very much, guys, for your attendance and watching us. Thank you also for your question, which inspire us for further development of our robots. I would like to thank our team, all of them, for their hard work. I'd like to thank Luca, Josue, Shunshu, Elias, and Tianji, who participated in the demo. And I would like to thank all of the guys behind the camera, Ehwa, Rati, Cecilia, Weming, and Matteo. Also, if you'd like to see more about us, you can visit our website. You can also see our YouTube channel, which we posted already on the chat. And finally, I would like to thank two of our college, Professor Dragos, who is the director of Rolls-Royce UTC, and Dr. Erwin Dong, who is the first person maybe started working on the snake-like robot in his PhD until now. And I would like to thank all of the members of the UTC who participate in developing this kind of robots. Thank you all.